All right, welcome to this video on monitoring pollution. And what we mean by pollution in this particular video is it breaks up into two places. We're going to talk about heavy metal monitoring and we're going to talk about eutrophication. Now, heavy metals, right? Heavy metal. Not that type of metal, but metal ions. So that could be lead, aluminium, lead, mercury. Could be a lot of different things there, but those ions come from industrial waste. Eutrophication, on the other hand, is when you get an enhancement of a nutrient entering the water body. Okay, so usually that's nitrates and phosphates. Okay, so then we'll talk about something called the nitrogen to phosphate ratio. So when we get a lot of nitrogen and phosphates released due to probably fertilizers and washing detergents, then the nutrient is increased. That causes algae to use that nutrients to respire and reproduce, increase their numbers, and then we have a flow-on effect to cause an algal bloom, right? And that whole process is called eutrophication, troph meaning food, eu meaning good for you or enhanced, so it's an enhanced nutrient, and that produces the results of algal blooms. Okay, all right, so let's look at how we monitor those. So how do we monitor? Well, let's just see if we can write it down here. Well, with ions here, we can monitor it with atomic absorption spectroscopy. We saw before that atomic absorption spectroscopy was specific for metal ions, so we can take water samples and then use that to monitor it. Very quick, very precise, and to very sensitive measurements, parts per billion. Okay, we can also do precipitation. So this is quantitative. This can be qualitative or quantitative, right? And remember when we looked in that in the previous video, we said that that will tell you the presence or absence of a metal ion. However, it's not very sensitive when we start getting down to being small amounts. So that's why atomic absorption spectroscopy is a lot better. We can do it quantitative. We can precipitate it, dry it, measure it, and work out by gravimetric analysis how much is there. But this is the way to go. Okay, that one there. How do we monitor eutrophication? Well, I'm going to have to rub off and make a little bit more room. So make sure you get that down, and I'll see you with a bit more room. We'll probably just get rid of this section. All right, welcome back. Now, you guys are probably too young to remember that, but there was a show, Welcome Back, Kotter. Welcome back, welcome back, welcome. Anyway, that's how the tune goes. So we've got our situation here where we've got enhanced nutrients of nitrates and phosphates. And how do we measure that? Well, we can measure it in two ways. One, we can measure it by an azo dye. Right, an azo dye, and that's mixed with cadmium, and that gives us a reaction in which we can measure the nitrites. Okay, so nitrates are converted to nitrites, and this method here measures the amount of nitrites, and then we can indirectly work out the amount of nitrates. Right, so that's the first one. You don't need to know much more detail than that. Now the second method, ammonium molybdate, is mixed with vitamin C to produce a blue complex. Right, it's a blue complex ion. And the concentration of that will be relative to the concentration of the actual phosphates, right? So this measures nitrates, I should have said, sorry. Nitrates. This measures phosphates. Right? So the concentration of the blue solution will be proportional to the concentration of phosphates. Okay, according to the Beer-Lambert law, but we don't have to get into that. But basically, right, you have your absorbance here, percentage absorbance. You have your concentration of your standard solutions, right? And then you'll get a relationship here. And so what happens is you will mix ammonium molybdate, vitamin C, and that will form a blue complex. The color of that you then put into a colorimeter. The colorimeter will work out a percentage absorbance. You will then find that percentage absorbance across here. Go to your standard graph, go down, and you'll have a concentration of phosphates. So we need to do that because by doing these two methods we produce what's called a nitrogen to phosphate ratio. And that nitrogen to phosphate ratio will give us an indication of the quality of the water body in terms of eutrophication. Okay, so we can also measure it indirectly with dissolved oxygen measurements, because we know that if algae is increasing in concentration and number, I should say, it's going to be respiring and it's going to be using a lot of dissolved oxygen. So if we have dissolved oxygen dropping and going down, we know that something must be causing that, and therefore we have an increase in algae, and that's due to an increase in these two here, right? So that's an indirect measurement, not as precise as these two, because these two will actually give you a nitrogen to phosphate ratio. So that's how we monitor those two ions and the ramifications of that in terms of eutrophication. We'll just remind you of what we have said before with eutrophication. We might take this over here in terms of the effects. Okay. The effects of eutrophication, of course, if the amount of algae is increasing, then it's going to block sunlight from reaching aquatic plants and therefore decreasing photosynthetic ability. So we get light being blocked, therefore decrease in photosynthetic organisms, therefore a decrease in dissolved oxygen, right? If we get a decrease in dissolved oxygen, that's going to have an impact on aquatic animals and plants. Okay. If we have more algae being produced, and we're going to get rid of this nitrogen phosphate ratio, if we have more algae being produced, they're going to release toxins into the water body. Those toxins are going to be probably consumed by farm animals, and so therefore you can be polluting and hurting the health of your farm animals if they're drinking from a river that is undergoing an algal bloom, right? So we can see that there is quite a lot of issues there with this scenario. Okay, hopefully that'll make sense, and I'll see you in the video where we put all this stuff together to answer a question.